This is a very quick lecture about embodied carbon in buildings. The reason why we are interested in embodied carbon is because of climate change. The production of materials for buildings causes the burning of fossil fuel and the use of energy, which in return emits CO2. So the manufacture of building products, like the manufacture of many other products, uses fossil fuel, which emits CO2. And embodied carbon is the carbon which is emitted in the manufacture and transport of the various building products. So this is from the mining and processing of natural resources to manufacturing, transport, and product delivery. So various building products emit different amounts of carbon throughout these various processes. And for example, bricks in the kilns requires the use of a lot of energy, which emits a lot of CO2. Now, building products emit CO2 throughout their life cycle, from extraction, manufacture, transport, construction, maintenance, refurbishment, demolition, and even recycling. This is the whole life cycle carbon emissions of building products. However, when we're looking at embodied carbon, we often consider this cradle to gate, which means up to the gate of the manufacturing point. So why does it matter? It matters because building materials and construction make up about 11% of the global CO2 emissions, including industry, transportation, and everything else. Building operations are still using more energy through heating, lighting, etc. So this makes out about 28% globally. But the thing is that because the building operation energy use is reducing with improvement in energy efficiency, building materials and construction overall make up a larger and larger part of the building energy use overall. Concrete is a major is a material that produces a lot of CO2 through its manufacture, in particular because of cement. Cement manufacture contributes to greenhouse gas, both directly through the production of carbon dioxide, when the calcium carbonate is thermally decomposed, producing lime and carbon dioxide, but also through the use of energy and the combustion of fossil fuels. Now, timber can have a overall embodied carbon which is negative in some cases. The thing is that trees absorb CO2 when they grow, and we talk about sequestered CO2 in this case. The manufacture of wood products can, however, emit some CO2, but the overall bill of CO2 tends to be much better than that of concrete. So therefore, when we look at the structure of a material, of a building, we often find that a timber building has a much better CO2, embodied CO2 overall. Concrete and steel structures can have 2 to 6 times more embodied carbon than a CLT structure. And if you look at beams of equivalent performance, as you can see from the numbers below, a glulam beam would have a much better performance in terms of embodied CO2. Now, often we can find embodied CO2 values expressed in kilograms of CO2 per kilogram of material. And you will find that materials like aluminium or fiberglass have very high embodied CO2 per kilogram of material. But if you look at the amount of materials used in a building, then, for example, steel, which has per kilogram a lower CO2 emission, would overall contribute to the embodied CO2 much more. So it is important to know the quantity of material in order to be able to do an evaluation and a comparison in different construction. Now, if we're looking at whole building elements, the overall result is that timber is going to have, it tends to be the preferred option from the point of view of embodied carbon. If we compare it to concrete, for example, in a floor structure or a steel subframe, timber has much, much lower embodied carbon emissions. And it's the same if we're looking at walls, where, for example, timber compares favorably in comparison to bricks. And even if we're looking at windows, timber comes out much better. Now, the thing is that this is not the whole equation. When we're looking at buildings, we need to also look at the whole life of the building. And in some cases, timber buildings can also result in some additional energy use, because perhaps they don't allow to use, they do not have any, timber doesn't have any thermal mass, so it doesn't allow to use some passive design technique. But this is another lecture. I hope you enjoyed this micro lecture, and thank you for listening.